Right now, tonight, if you step outside and look up at the constellation Orion, you'll spot a faintly reddish star glowing in the upper left corner of the hunter's shoulder. It's not hard to find. People have been staring at it for thousands of years. The ancient Egyptians knew it. Arab astronomers gave it a name. Medieval sailors steered by it. And for most of recorded history, it just sat there quietly doing what stars do, burning. But in 2026, everything we thought we understood about that star changed. Hubble, the most famous telescope ever built, has been watching it closely for nearly 8 years. And what it finally confirmed, combined with data from the most powerful ground-based telescopes on Earth, has stunned every astronomer who's seen it. That star isn't dying alone. It has a hidden companion. And together, they're giving scientists the closest front-row seat to a slow-motion stellar explosion that anyone in human history has ever witnessed. If you want to understand what's really happening up there right now, stick around. Hit subscribe, because this channel covers exactly this kind of thing every single week, and you won't want to miss what's coming next. The star we're talking about is Betelgeuse. And to understand why Hubble's confirmation is so extraordinary, you first need to understand what Betelgeuse actually is, because most people have no idea how enormous and strange this object really is. Betelgeuse is classified as a red supergiant, the largest category of star in the known universe. When astronomers measure its diameter against our own sun, the numbers become almost impossible to wrap your head around. Betelgeuse is roughly 764 times wider than the sun. But here's the comparison that really drives it home. If you remove the sun from the center of our solar system and put Betelgeuse in its place, its surface wouldn't just cover our sun, it wouldn't just swallow Mercury, it wouldn't just engulf Venus, it wouldn't just consume Earth and Mars. It would stretch past all 4 rocky inner planets and reach into the asteroid belt, swallowing Jupiter under some size estimates and leaving only Saturn and the outer planets outside its surface. A single star sitting where our entire inner solar system currently sits, burning hot enough to be seen with the naked eye from 650 light years away. That's Betelgeuse, and it's dying. The dying part isn't news. Astronomers have long known Betelgeuse is in the final phase of its stellar life. A red supergiant is what forms when a massive star runs low on hydrogen fuel in its core. The core contracts and heats up. The outer layers expand enormously, and the star swells to hundreds of times its original size. Its surface cools, which is why it glows red instead of white or blue. And eventually, once the core completely runs out of fuel and can no longer resist its own gravity, the whole thing collapses inward in a fraction of a second, then rebounds outward in the most violent explosion the universe produces, a supernova. When Betelgeuse finally goes supernova, it will be visible from Earth during daylight. It will likely outshine a full moon. It will be bright enough to cast shadows at night for weeks. The last supernova visible to the naked eye from Earth occurred in 1987, and that one was in a neighboring galaxy. Before that, you have to go back roughly 4 centuries to find one close enough to truly stun the people who witnessed it. When Betelgeuse eventually explodes, it will be the single most spectacular astronomical event in recorded human history. The question that has haunted astronomers for decades is simple: when? For years, the evidence kept pointing in a direction that made scientists genuinely uneasy. Betelgeuse was dimming and brightening in strange, inconsistent ways. It was ejecting huge amounts of material from its surface. Its atmosphere behaved in ways that didn't fit the simple picture of a single, aging star quietly burning through its final fuel. Some researchers began suggesting the timeline for the explosion might be shorter than previously believed. Some estimates pointed to decades rather than millennia. Then, in late 2019 and early 2020, Betelgeuse did something that made global headlines. It dimmed dramatically. Its brightness dropped by roughly a full magnitude, reaching levels never before recorded in modern astronomical history. Social media exploded. News outlets around the world asked the same question. Is Betelgeuse about to explode? Astronomers scrambled to analyze the data, and the answer that came back wasn't what anyone expected. It wasn't dying, not yet. It had done something else entirely, something never before directly observed in a star of this scale. It had ejected a massive chunk of its own surface, a cloud of hot plasma the size of a small planet, which then cooled in space and formed a temporary dust cloud that blocked its light from reaching Earth. Betelgeuse had essentially sneezed, a titanic, never-before-seen convulsion that flung billions of tons of stellar material into surrounding space. Then it began recovering. That episode, which astronomers dubbed the Great Dimming, left behind a puzzle. Why did it happen? What caused a star this large to suddenly shed a piece of its own surface? And why was Betelgeuse showing such unusual brightness patterns to begin with? For decades, astronomers had tracked several rhythmic dimming and brightening cycles in Betelgeuse happening simultaneously, roughly 180 days, roughly 230 days, roughly 420 days, and a much longer, slower cycle of about 2,100 days, or roughly 5.7 to 6 years. 3 of those cycles made sense. They matched the known physics of a large star pulsating, swelling and shrinking, breathing in and out the way dying stars do. But that longest cycle, the roughly 6-year variation, didn't fit any known pulsation model for a single star of Betelgeuse's type. Something else was driving it, and for years, nobody could figure out what. Then in 2025, the answer arrived from a direction few had fully anticipated. 2 separate research teams, working independently, reached the same conclusion at almost exactly the same time. Betelgeuse isn't alone. It has a companion, a second star, orbiting the red supergiant on a roughly 6-year cycle, close enough that it actually passes through the outer layers of Betelgeuse's enormous extended atmosphere with every orbit. Researchers named this companion in a way that honors Betelgeuse's own Arabic origins. Betelgeuse's name comes from Arabic words meaning the hand of Al-Jawza, a female figure in Arabian astronomical legend. So the companion was named Siwarha, the Arabic word for her bracelet. That poetic choice turned out to perfectly capture what the companion does. It circles its massive partner like a bracelet around a wrist, orbiting once every 2,100 days. Its gravitational presence leaves a trail of evidence in Betelgeuse's behavior that researchers had been observing for years without understanding the cause. Confirmation came in January 2026, when NASA announced that Hubble Space Telescope data, combined with observations from the Fred Lawrence Whipple Observatory and the Gemini North Observatory, had delivered the clearest evidence yet that this companion is real, and that its effect on Betelgeuse is both visible and measurable. The research team, led by scientists at the Center for Astrophysics at Harvard and Smithsonian, drew on nearly 8 years of continuous Hubble observations, 8 years of watching Betelgeuse's chromosphere, its deep atmosphere, respond to something orbiting inside it. Here's how the team described what they found. Think of a boat moving through water. The boat leaves a wake behind it, a trail of disturbed water radiating outward from its path. The companion does essentially the same thing as it moves through Betelgeuse's vast outer atmosphere. It generates a dense wake of gas, a trail of material pushed, stirred, and compressed by its gravitational pull. That wake expands outward through Betelgeuse's atmosphere in a pattern that repeats with every orbit the companion completes. That repeating pattern is what Hubble detected, not just once, not just as a hint, but clearly and consistently across nearly 8 years of data. The wake shows up in the spectrum of light coming from Betelgeuse. When scientists pass a star's light through a spectrograph, they can identify the specific colors produced by different chemical elements in its atmosphere. Shifts in the precise wavelengths of light from those elements reveal how the gas is moving. What Hubble and the ground-based telescopes picked up was a repeating pattern of spectral disturbances in the motion of gas in Betelgeuse's outer atmosphere, lining up perfectly with the companion's orbit. Roughly every 2,100 days, shortly after the companion passes in front of Betelgeuse as seen from Earth, the wake appears in the data. It shows up, expands, fades, as the companion swings to the far side of Betelgeuse, and then reappears roughly 6 years later. That pattern is now repeated at least twice across the 8 years of Hubble data researchers analyzed. Lead researcher Andrea Dupre of the Harvard-Smithsonian Center for Astrophysics summed up the discovery this way. Finding the wake from its companion means we can now understand how stars like this evolve, shed material, and eventually explode as supernovae. So, what does this companion actually look like? It's nothing like Betelgeuse, a relatively modest star by cosmic standards. A hot, blue-white main sequence star with somewhere between roughly 1.4 and 2 to 3 solar masses, depending on the measurement method used. In visual terms, if our sun were a beach ball, the companion would be roughly the same size, or a bit larger, while Betelgeuse would need to be the size of a large sports stadium sitting beside it to represent the true scale difference. The companion orbits at a distance of about 4 astronomical units from Betelgeuse, roughly the same distance Jupiter sits from our sun. But because Betelgeuse is so unimaginably large, that distance isn't actually far from the red supergiant's surface at all. The companion isn't orbiting at a safe remove. It's orbiting partly inside Betelgeuse's extended outer atmosphere, which reaches far beyond what you'd call the star's visual surface. With every orbit, the companion plunges through that outer atmosphere, stirring up gas and generating the wake that Hubble has now confirmed is clearly detectable across multiple orbital cycles. Then, in July 2026, just weeks before this was written, astronomers delivered the next piece of the story. Using the Very Large Telescope in Chile, one of the most powerful optical telescope systems on Earth, researchers directly imaged a candidate companion at the exact location the models predicted. The image was published in the journal Astronomy and Astrophysics in late July 2026. The companion showed up right where orbital mechanics said it should, based on timing models built from Hubble's data and earlier Gemini North observations. That direct imaging result hasn't yet been independently confirmed by a second observation, because the companion has since moved to the far side of Betelgeuse, as seen from Earth, and won't be in a favorable viewing position again until November 2027. Telescope time for that follow-up observation has already been awarded to the research team. Still, the combined evidence, 8 years of Hubble atmospheric wake detection, earlier brightness pattern analysis from 2 independent teams, a marginal 2025 detection from Gemini North, and now the 2026 Very Large Telescope Imaging Candidate, has been described as the strongest evidence yet that Betelgeuse is truly a binary system. One researcher who has studied the star for years responded to the imaging result by saying, "It's remarkable that something as fundamental as its binary nature is still being discovered in 2026. So, what does the existence of this companion change about Betelgeuse's future? This is where things get both fascinating and, depending on whether you were hoping for an imminent cosmic fireworks show, a bit sobering. The mystery of Betelgeuse's 200-day brightness cycle is now explained. It's the companion. As it stirs Betelgeuse's atmosphere on each orbit, it creates the brightness variations that puzzled astronomers for decades. And with that explanation comes a revised picture of what stage of life Betelgeuse is actually in. The unusual brightness patterns that some researchers had read as signs of a star rushing toward collapse now have a different, more stable explanation. Updated models that factor in the binary companion place Betelgeuse in what's called a stable helium-burning phase. After a massive star exhausts the hydrogen in its core, it begins burning helium, a phase that can last a long time. With the companion's gravitational influence now factored into the calculations, estimates for when Betelgeuse will finally explode have been pushed significantly further out. Current scientific consensus places the supernova anywhere from tens of thousands to roughly 100,000 years from now. The companion star shifted the timeline dramatically. There's also an extraordinary subplot buried in this discovery. What happens to the companion when Betelgeuse eventually goes supernova? The answer is almost certainly immediate destruction. When Betelgeuse's core collapses in a fraction of a second, the resulting explosion will release more energy in that instant than our sun will produce across its entire 10 billion year lifetime. A shockwave of unimaginable force will race outward through the expanding stellar material at a fraction of the speed of light. The companion, orbiting deep inside Betelgeuse's outer atmosphere, will be consumed and destroyed almost instantly in the fireball. It won't survive. But before that happens, tidal interactions between the two stars are expected to gradually pull the companion inward. Researchers believe that within roughly 10,000 years, long before Betelgeuse reaches supernova, the companion may be swallowed entirely. Betelgeuse may consume its companion star first, and that engulfment event, whenever it happens, would itself be an astronomical event without precedent in recorded human observation. This discovery also has implications well beyond the Betelgeuse system. One persistent mystery in stellar astronomy is known as the red supergiant problem. Theory predicts that massive red supergiants should be the most common type of star to explode as core collapse supernovae, the kind produced when a star runs out of nuclear fuel. But when astronomers comb through historical records looking at stars present before known supernova explosions, they keep finding something odd. Many of the pre-explosion stars don't match the red supergiant's theory predicts. In one case, confirmed in February 2026, a massive star 2.5 million light-years away simply vanished without the bright supernova explosion that should have accompanied a death of that magnitude. It apparently collapsed directly into a black hole, shedding its outer layers in what one research summary called a slow-motion cosmic fade-out with no dramatic explosion at all. The existence of hidden, previously unknown companion stars may be a crucial missing piece in explaining the red supergiant problem. If many massive dying stars actually have close companions, shaping their late-stage behavior, influencing mass loss, altering rotational momentum, or even being swallowed before final collapse, then the gap between the predicted appearance of a pre-supernova star and what's actually observed may be explained by that hidden companion. Andrea Dupre put the broader significance directly. Betelgeuse is giving us a front-row seat to watch how a giant star changes over time. Finding the wake from its companion means astronomers can now understand how stars like this evolve, shed material, and eventually explode as supernovae. She added that other red supergiants, showing similar long and short brightness cycles, may also have hidden companions that have simply never been detected. Betelgeuse may be the clearest example of a pattern that's actually widespread among massive dying stars, one astronomers simply couldn't see before because they weren't looking for it. Now they are. And in the years ahead, with Hubble still operating, and the next generation of extremely large ground-based telescopes coming online, researchers expect to find companions around other massive stars previously thought to be single, slowly burning alone. There's also something genuinely awe-inspiring about the timing of this story that's worth sitting with. The light from Betelgeuse that Hubble and ground-based telescopes are analyzing right now left the star roughly 650 years ago. When the oldest light in Hubble's current dataset departed Betelgeuse, it was the year 1376. The first complete version of Geoffrey Chaucer's Canterbury Tales hadn't yet been written. The printing press hadn't been invented. European explorers hadn't yet reached the Americas. That's the light Hubble is measuring. And within that light, already 650 years old by the time it reaches our instruments, scientists can read the wake of a companion star, detect disturbances in an atmosphere spanning hundreds of millions of miles, and reconstruct the orbital dynamics of a binary system. Humanity had no idea existed until last year. The telescope isn't just pointing at space, it's reading a message sent before the Renaissance that's only just arrived. For the next major chapter of this story, the date is already marked. November 2027 is when the companion is predicted to reach its widest apparent separation from Betelgeuse as seen from Earth, the next great observing opportunity. Multiple research teams already have telescope time secured. The Very Large Telescope, the Gemini North Telescope, and very likely Hubble itself will all be pointed at Orion's shoulder at that moment, waiting to capture the clearest possible image of the companion in a configuration where its light can be most cleanly separated from Betelgeuse's overwhelming brightness. If those 2027 observations confirm what the 2024 and 2025 detections suggested, and what the 2026 Very Large Telescope imaging showed, the binary nature of Betelgeuse will be established beyond any remaining doubt, and the scientific effort to study how two such differently sized stars interact, exchange material, and eventually end their shared existence in the most energetic explosion the universe can produce will have decades of work ahead of it. The most famous dying star in the night sky just got a lot more interesting. Tonight, if you step outside and find Orion, look once more at that reddish glow on the hunter's shoulder. What you're seeing isn't just a dying star, you're looking at a binary system. A giant, swollen red supergiant so enormous it would swallow everything from our sun out to the asteroid belt, slowly losing mass, pulsating, stirring its own outer atmosphere as an invisible companion orbits every 6 years through its outermost layers. Two objects locked in a gravitational relationship that will eventually end in an explosion bright enough to be seen in daylight from Earth. Nobody alive today will see that explosion. But every time Hubble turns its instruments toward Betelgeuse, we get a little closer to understanding exactly how and why it will happen, and what it tells us about the lives of the largest stars the universe is capable of building. This slow-motion explosion has already begun, spread across thousands of years of stellar dying, and for the first time in human history, we have the tools to watch it happen in real time.